Good morning.
Hello.
Morning
Today
for us.
it's probably late at night for you. But today we're going to talk about Chapter 8.3, Part 2, Algebraic Solutions of Trig Functions.
Okay, let me give you a warning before we start. This is hard and it's not hard. It uses stuff that we've used before. It uses long time ago algebra, and all of it comes into play here. So this is not something you need to be watching when you only have 15 minutes to watch, because this is going to take us a while to do what we have to do. All right. Okay, so our first problem that we're going to do is find the solutions of 4 sine squared plus 5 sine x plus 1. Well, if you look at this, it kind of looks like quadratic stuff that we factored. So let's go back to our dear friend u. Let's let u equal sine of x. If u is sine of x, then this becomes 4u squared plus 5u plus 1 equals 0. And that we can factor, you can use whatever technique you use, but this is going to factor 4u plus 1 and u plus 1. Signs are the same, so that we have a plus here. And so we have this is equal to 0. Well, okay, that means 4u plus 1 equals 0, or u plus 1 equals 0. Well, this is easy. Subtract 1. Okay, here we're going to subtract 1 and divide by 4. So now this you might think is really easy. We're done, but we're really not, because what was u? U was the sine of x. Okay, so this is the problem we have to solve, and this is the problem we have to solve. Now, oopsie, one of these is easy to solve. I'll bet you can tell which one it is. It's our friend sine of x is equal to -1. This you should recognize with our circle here. Where is the sine value? You remember that your x and y on the unit circle, the x coordinate is your cosine and your y coordinate is the sine. Okay, so we know we want our y coordinate to be -1, so we know we're down here at 0, -1, and that happens at 3 pi over 2. But alas, what's the problem with 3 pi over 2, Ms. Miller?
It is not in the interval for sine, which is negative pi over 2 to pi over 2.
Okay. Notice, by the way, it says here for us to solve in the interval of negative pi to pi. That means we're being given a specific interval for answers. So we still have to use this right here as we find our answers, but then we're going to have to take the answers we get and figure out what to do with them so that all of the answers lie in the interval negative pi to pi. So we see that that this is at 3 pi over 2, but the proper answer in the right interval for our x is negative pi over 2. Now, you just got done with section 8.2, so we shouldn't have to explain that, and we're not going to. Now, our other problem here, this you recognize
On the graph.
Oh, yeah, sorry.
On the
And
graph.
Ms. Miller wants us to point out, look, there is negative pi over 2. Thank you.
You're welcome.
Thanks for catching that. All right, now you can see that our other problem here, though, that is clearly not a ratio we recognize on the unit circle. And by the way, let's take this time to refresh your memory. If you see a ratio 1/2, square root of 3 over 2, square root of 2 over 2, 1 over the square root of 3, square root of 3 over 3, or 0, 1, or negatives of any of those, you know you're talking, oopsie, wait a minute, square root of 3 and 1 over square root of 3, well, those would be tangent values. So 1/2, square root of 3 over 2, square root of 2 over 2, zeros and ones. Any of those positive, negatives, you know you have got a unit circle angle. So 1/4, or -1/4 in our case, is not a unit circle angle. So we are going to have to use the calculator on this part of the problem. So the thing that's important is understanding what that answer is that the calculator is going to give us. Now, we can see that this value is negative, so our answer, x, is going to be, what is it going to give us an answer of? Between what and what?
Negative, let's see, 0 and negative pi over 2.
Yep.
Negative pi over 2 and 0.
Yeah, and we know it's not at negative pi over 2, because at negative pi over 2, sine is -1. So we know it's got to be bigger than negative pi over 2 and smaller than 0, and we know it's not at 0 because the sine of 0 is 0. So we know that our answer should be in this interval. So we're talking about -1.57 and 0. So when the calculator gives us an answer, we expect it to be in that interval, but we're going to have to do something with it. Yes?
We also know that the sign of x equals negative 1/2 happens at pi over 6. So we
Negative pi over 6.
So we know that it has to be it has to be smaller than negative pi over 6.
Yeah, it has to be smaller than negative pi over 6. Exactly, because if we took a triangle where there is negative 1/2 for our y-coordinate, and this angle is negative pi over 6, pi over 6, this is negative 1/4 for that length of that side, for that side.
And we can't do the ratio of, it's 1/2 of that. No, we can't do that.
No, we can't do that. It doesn't work that way. But what we do know we are bringing to the table logical reasoning. And guys, this is
where your calculator can't do this for you. You have a brain, and this is what makes it important for you to use your brain.
right. And the thing here's one of our concerns, and Ms. Meller and I both see this throughout, and I've seen it for as long as I've been teaching pre-cal and calculus. Those of you that try to memorize your way through a course, you are really hitting the wall at this point. If you have tried to memorize, when I see this, I do this, when I see this, I do this, and you're just trying to memorize all the steps, if you haven't hit the wall yet, you will, because there's just so many steps your brain can memorize. So it is important that you start forcing yourself to think about it, okay? We love you. We want the best for you. You need to learn to think. All right, so here we go. We know that our angle is going to give us, our calculator is going to give us a number between negative 1.57 something and 0. And when we do x equals the inverse sine of negative 1/4, in other words, tell me the angle whose sine is negative 1/4, we get for our second angle, make this x2, x2 is, the calculator pops out, it is about, we should always use approximations here, negative 0.254. Now, we know that this is plus, our period is 2 pi k. And we're going to come to use that in a little bit. Now, what we also know about sine is, again, let's see our interval. Our interval has to be between negative 3.14 and 3.14. This is how we have to answer these. We are in a specific interval. Okay, so we have to pay attention now to our answers. Does this point lie in this angle lie in the interval? Yes. So we're good with that solution. We know that is one of our solutions.
And
right
if
there.
I add plus or minus 2 pi, I'm not gonna get another one in that interval.
Right. Yeah. To negative pi over 2, because if I add 2 pi, I'm going to go around counterclockwise and end right back up at this point.
Which is 3 pi over 2.
And if I add negative 2 pi, I'm going to end up at negative 5 pi. Anyway, same place. Now this one is a little more to think about, because where is negative 2.54?
It's in quadrant 4.
It's in quadrant 4, and so it goes there. But do you know sine is negative in 2 places? I have that point, and I have the corresponding point over here in quadrant 3. So what we need to do, so this angle here becomes a reference angle here, and there's a couple of ways we can think about what our solutions are. First is, does negative 2.54 lie in the interval that we need?
Yes.
Yes, it does. So that's another solution. So we can now say our second angle is negative 0.254. Let's see if we have that up here somewhere. Oh, I'm going to bet it's right there.
Yep.
So how do we find this angle here? Well, we have a couple of ways to do it. One way is to think of it like this. x3 is pi minus that angle we just found, plus 2 pi k. And pi is 3.14. And that's going to be 3.14 plus that decimal there. And that gives us 3.394 plus 2 pi k.
Ah! Wait! 3.394 is not in the interval!
Boo! So that is not in our interval. So now we have to play around with that. Well, this is where that beautiful, what in the world does K mean, comes in. So for our x2, we know we have an x2, but I'm going to use this. Let's let K equals 0 in our x2, and that gives us x2 equals negative 0.254 plus 2 times pi times 0. Okay, that's one answer. Now how do you think we're going to go with x3? Well, if we look up here for x3, if k is 0, that's going to give us this point.
It's not in the interval.
If k is negative 1,
maybe it is.
that would be negative 1 times 2 pi, which is negative 6.28, plus 3.394.
So 2 pi minus something bigger than pi is going to be less than pi.
So that would work. But here's another way. That's a lot of multiplying I don't want to do. How about we let k equal negative 1 in this formula in this formula right here. So we're going to say, no, in this formula.
You're right. You're right.
So x3 equals 3.394 plus 2 pi, k is negative 1. And I'm just going to tell you, save you the time. We're not going to try to multiply this in our head because we don't have time on the video. We get this, and there you go. Is that in our interval?
Yes.
So we have our three answers. x1 was the simple one. When you have one that is a nice, beautiful value, like one of our unit circles, answer it that way. When it's not, go ahead and resort to the calculator, and notice how what we had here at negative 2.54, that 2.54 became a reference angle here. So if you look at that picture, do you see that here we are at pi? Do you see we could have taken pi and just added the absolute value, added the reference angle, 0.254, and look what we get, 3.394, which is not that one. Oopsie.
Which is
that one's not in.
No, it's
I have to subtract.
Right here.
Yeah. Yeah, so that would give us the answer up there, but again, that's not in the interval that we need it because we need our answer to go from negative pi to pi.
Okay, but if you look at this, right here, if I go this direction, this is negative pi, and my angle that I want is this one right here. So if I take negative
And that's
pi,
this angle.
if I take negative pi and I subtract the...
No, add.
I'm going to subtract it from...
Add that.
I'm going to subtract
Oh,
it
subtract
from
it, which adds it, yes. Subtract.
negative 0.254.
Yeah.
Okay, then that would be negative pi plus 0.254, which gives me this thing right here.
And when I was saying adding, I was meaning to add it as the reference angle. Yeah, the absolute value. Remember that reference angles are always positive acute angles. They're between 0 and 90 or 0 and 1.57 when we're dealing with radians. All right, so that is a lot to think about in that one problem.
Okay, so let's look at the next one. This one right here has two different trigonometric functions that we're using. So we need to look at it as an algebra problem. We can't just divide both sides by cosine of x because that would delete some of our values and solutions that we're looking for. So let's just look at what we have. Let's say, oh look, this looks something like this, doesn't it? Because if cosine x is x and sine squared x is y squared, then this is what it looks like. Well, what I would do here, some of you would probably say, oh, divide by x. I can't divide by x.
You're cutting out a solution if you do that, and so that's very, very, very bad.
So I'm going to subtract x from both sides, and now I would factor the x out and get y squared minus 1 equals...
Oh, difference of two squares!
Oh, boy!
Wow!
Okay, so we can solve this. We can set x equal to 0. We can set y squared minus 1, which is actually y minus 1 times y plus 1 equal to 0. All of these equal to 0, and then solve it that way. Okay? So that's what we would do if we were solving for the
basic algebra.
basic algebra problem. But because I want to show you what it looks like, with, here, I'll make it small.
Yeah, just do it right over here.
What?
Okay, that'll work.
I'm going to make it smaller. Just because we want you to see what it does with trig functions, we're going to do it with the trig stuff. So here we have cosine of x, sine squared of x equals cosine of x. I'm going to subtract cosine from both sides. So cosine of x, sine squared of x, minus cosine of x equals 0. Factoring out cosine of
Greatest
x,
common factor.
sine squared x minus 1 equals 0. But wait! Why do I want to make this a difference of two squares when it's a special...
It is a reverse of it. 1 minus sine squared would be the
It's
identity,
negative.
but it is so easy as a difference of two squares because look at our solutions. You can see that we have something happening here, and something happening here, and something happening here, and maybe, just maybe, if we factor... What's factored?
It's easily
Easy
separated.
to done, yeah.
So let's just go ahead and separate that. We've got cosine of x equals 0 and sine squared x minus 1 equals 0. Okay, well, I can go ahead and solve this one.
Yeah.
This one's easy because if I look at my unit circle, when the cosine is 0 between 0 and pi, that would be right here. Okay, so that's at x equals pi over 2. Okay, that's one solution. All right. The next one, let's go ahead and break this into two pieces. We've got sine of x minus 1 equals 0 and sine of x plus 1 equals 0. Okay.
That's because that was a difference of
It's
two
a difference of two
squares,
squares.
and we factor it.
All right. So over here, I'm going to add 1 to this one. So we've got sine of x equals 1. And when does that happen on our unit circle? For our right values.
Mhm.
For our right values. Let's see. That would be right here. Okay. So that's pi over 2. X equals. I'm going to put x1, x2.
Yeah.
And let's see, over here I'm going to subtract 1. Sine of x equals negative 1. So when does that happen? That happens here.
Oh, 3 pi over 2!
No, wait, that's not in the interval.
Oh, yeah, not in the interval.
So x equals negative pi over 2. x3 equals negative pi over 2. Okay, so there's 3 solutions. Now here's our problem. This one's in there twice.
Yeah.
Okay, but let's see. We're going to go ahead and we're not asking you for only ones in an interval. We're asking you for a lot of different ones. Okay, so we
should have really answered x1
equals
as...
pi over 2 plus 2 pi k.
Okay, so that's the answer we really want.
Okay, this one right here, we already have it, so we're not going to use this one anymore. We already have it right here. Okay, and this one we have x3, which is, negative pi over 2 plus 2 pi k. Okay? And
if you look at our window up here, you should recognize 6.28, that's 2 pi. And so we're basically going from 0 to 2 pi in our angles. This negative 0.1, that's to give us a little bit of a window. And you can see that what we also have here is this right here tells us your increments are 0.79, which you need to recognize as pi over 4. Okay, so here's 1 pi over 4. There's 2 pi's over 4. There's 3 pi's over 4. There's pi. That answer didn't come up, right? Okay, maybe if I did the right thing here. Let's see. That's right. That's pi. That's 2 pi. Here is 3 pi over 2.
but we're looking where the two equations are equal, not the zeros.
Oh, you know what? What a careless little thing we just did. And that is why it is important for you to pay attention to actually what's on your calculator. Because a lot of you, we did that on purpose, a lot of you would go with that answer, and that's not one of the answers
In
we
fact,
want. It is
some
a
of you did
0.
that on your tests.
Yep, you did. It's a 0 of cosine function. Well, it's a 0 of something here. It's the 0 of the sine, but it's not one of the points of intersection that we want. So you've got to be sure you answer the questions being asked. So how in the world are we getting to that point?
Well, that is negative pi over 2 plus 2 pi k.
So if we let k equal 1, our x3 would be negative pi over 2 plus 2 pi k, which is...
Oh, k is 1.
Oopsie, yes, k is 1. 2 times pi times 1. So that's negative pi over 2 plus 2 pi. Oh, there you go, 3 pi over 2. So that takes care of showing us that answer. So now we can live with that as a good solution.
Now, here's the thing. I'm going from every pi over 2 to every other pi over 2 increment, okay? And then every negative pi over 2 to every one of those.
Oh,
okay?
yeah, so if we look at it on a circle, let's do this one. If we go from every pi over 2, that's that one.
And then it's going over and around the circle to get to the
So
next
we can.
one.
So that one's always going to end up there.
And this one right here is always coming around here, and it's going to end up here as well. But if we look at it, I'm only going from here to here, and then back again until I get another solution. So if I think about this, x is really pi over 2 plus pi k, because it only has to travel around half the circle, or 1 pi, to get to the next solution. And so I can actually combine my two solutions, x1 and x3, into an overriding solution. We'll just call it x. That's pi over 2 plus pi k.
Because this one we love because it covers all the bases. Now, you're not always going to be able to do that, but that's kind of a really neat thing about this problem.
And it's because they're quadrantal angles.
Yeah, it is. This is an unusual situation, but again, always you have to bring everything to the table, which means you have to think about a lot. You have to do a ton of analysis.
All right, so go to section 8.3 and work number 37, no calculator, and number 43, where your calculator's okay.
Okay, so the problem we have with this one is we have different functions. And when we have different functions, we can't even think about factoring. What we need to do is get everything in the equation to be in terms of one function. And now you have to go back to section 6.5 and remember your identities. Okay? And the identity that we have that is useful here is that, well, let's see. I can't get rid of cosine very easily, so what I want to do is see if I can write sine squared in terms of cosine. And we have the nice little Pythagorean identity that sine squared can be written as 1 minus cosine squared.
Sine scared.
Sine scared. And it does scare us. All right, so here we go. -6 parentheses. 1 minus cosine squared of x plus cosine of x plus 5 equals 0. I honestly don't know how schools teach this course in the very beginning of, teach this topic in the beginning of your pre-cal, because there's too much algebra you don't remember. All right, so what we're going to do is we're going to distribute the -6 plus 6 cosine squared x. Okay, that's now distributed. Plus cosine of x plus 5 equals 0. Beautifully, my cosine squared became a positive sign in front of it. So I'm just going to bring it, oopsie, not sign, whoopsie. See that kind of mistake? That can happen. Cosine squared of x plus cosine of x. We're going to write this in the traditional form. And -6 plus 5 is -1 equals 0. All right. There's what we're going to work with, and we want to factor it. Well, we could spend forever factoring it, but I'm going to think that maybe 2 cosine x in this parentheses and 3 cosine x in this parentheses, that's going to give me 2 times 3 is 6. The only way to get a 1 is a 1 and a 1. This is one that's pretty easy to do by trial and error, and I need my outer and my inner to subtract to 1, and I can do that to a positive 1. So this is a positive sign here and a negative sign there. Let's see.
Yeah,
this gives us -2 cosine x, positive 3. Okay, here it is. And so what we have is 2 cosine x plus 1 equals 0, or 3 cosine x minus 1 equals 0. All right. Subtracting 1, dividing by 2. Okay, guys, you should be able to do that in your head without much work. Okay, adding 1, dividing by 3 gives us that. Now
If
here,
you answered, happy answer.
yeah, good answer. We like this one. Bad answer, calculator, okay? Which means we're going to have to think some more on that one. So here we go. Cosine, the angle whose cosine is negative pi over 2. All right, when we think about, that's our negative pi over 2 has to be the x-coordinate. Square root of 3 over 2 is the one that goes with that. And our cosine is negative, which means we're in quadrant 2. So we have to be at negative 1/2 for x, positive square root of 3 halves there. So our angle is 2 pi over 3. Okay? Plus your 2 pi k because it doesn't say to do in specific intervals. All right, so there's one answer. We like that one. Okay? But,
The next one requires un calculadora.
yeah, so I'm going to call that one x1. So now we're going to come over here, and just to save you the time, we know that x is cosine inverse, the angle whose cosine is 1/3. What quadrant should our answer be?
It's in quadrant 1 because it's positive.
All functions, when you do the calculator, if your sine, cosine, tangent, secant, cosecant, and cotangent values are positive, all of those will give you a quadrant 1 angle. So we now know we're going to get something between 0 and 1.57, so we're just kind of thinking ahead. And so x could be equal to, and it turns out 1.231 plus 2 pi k. Now, here's the other thing that we have here. X, cosine is an even function, okay? And so there's another solution I could also have here. I'm going to call this one over here x3 because x2 would be negative 2 pi over 3 plus 2 pi k. Now that's not in our interval that we're thinking about, but it is true that that cosine is negative there. Why would I want to think about that? Because we're going to look at these answers up here and try to figure out what we have. And if that's the case here, then x4 would be negative 1.231 plus 2 pi k. So our answers are 2 pi over 3 plus 2 pi k, negative 2 pi over 3 plus 2 pi k, 1.231 plus 2 pi k, and negative 1.231 plus 2 pi k.
So the negative 1.231 is about that one.
Mm-hmm.
So that's this one. Okay.
The positive.
The positive 1.231 is about there.
Mm-hmm.
The negative 2/3 pi is about right there, because if this is pi, that looks like it's about 2/3.
Mm-hmm.
And the x1 is just positive 2/3 pi is right there.
And see, the use of this graph here is that you can see why we want to look at it on the graph whenever we can is we want to think about how do I get all those answers represented by the equations. If you had left out the negative possibilities, you wouldn't have all of those answers represented. Okay?
Because if we actually zoomed out, you could tell that these are different bumps here. We got a short bump and a tall bump. Short and then tall, okay? So these are all different zeros.
Right. The blue one is on the decreasing side of the short fall, and the green one is on the decreasing side of the long fall.
Yeah.
And the red one is on the increasing side of the long rise, and the black one is on the increasing side of the short rise. So you have to have your points corresponding to every possible point that could happen. I recommend maybe that you go ahead and graph this and expand it just to have a look at it. Maybe go negative 3 pi to 3 pi. Change your window, negative 3 pi to 3 pi, and look at what's happening. And then you'll understand why all 4 of these answers are needed.
Okay, so here's our next example. We're going to solve secant squared of x minus 2 tangent of x equals 3. Ew!
Two functions.
We can't separate them by just factoring something out, so we have to actually use our trig identities. So recall from section 6.5 that secant squared, I say it one way and I write it another. Secant squared of x equals 1 plus tangent squared x. Okay, so we're going to use that information. I do that every day. All right, we're going to use that information to substitute it here. So we have 1 plus tangent squared x minus 2 tangent x equals 3. Okay. Then what we're going to do is we're going to go ahead and rearrange this nice thing into a quadratic. So we have nothing being multiplied, so it's tangent squared x minus 2 tangent x plus 1 equals 3.
Oh, let's do that step in 1.
Well, just so we don't
Oh, okay, yeah.
confuse
Go ahead
anybody,
and write one more
I'm
step.
going to go ahead
Yeah, go
and write one more step. So we have tangent squared x minus 2 tangent x. Subtract 3 from both sides, I get minus 2 equals 0. Okay, now we're going to factor this lovely thing. So if I use u substitution, I would see that this is u squared minus 2u minus 2 equals 0.
That doesn't factor.
Ew!
You don't have factors of 2 that subtract to 2. There's no way to do that.
So we have to use the quadratic equation.
What? Oh, well, that's useful because your A is
Formula.
1,
Yep.
your B
Is
is negative
-2.
2, and your C is negative 2.
Okay, so we have x equals negative
Well, it's
b
not X.
plus minus, u.
Let's use U, and then it's not really X. It's going to actually
U.
be tangent X. So we'll make it U.
u equals negative b plus minus square root of quantity u squared. Which
B
is
squared.
B squared.
Negative 2 squared.
Minus 4 times 1 times negative 2.
Negative 2.
All divided by 2 times 1.
Done.
Okay, not done, but closer to being done.
Oh.
Okay, so this equals, I'm going to just go the short route. I'm going to tell you what it is. U equals 1 plus or minus the square root of 3. Okay.
Well, let's go ahead and do one more step. Let's do one more step. Do the actual 2.
All right, 2 plus or minus the square root of, we'll say 12.
12
There we go,
over 2.
over 2.
And you do a ton of simplifying. Okay.
So that gives us, we know that we can factor out, this would be 2 square root of 3, 2 plus or minus the 2 squared to 3 over 2, which you can factor out 2, so that's u equals 2 times 2. 2 times 1 plus or minus the square root of 3 over 2, which equals u equals 1 plus or minus the square root of 3.
Cool.
Okay,
So we think
know
we're
that.
done. But we're not done. No.
Because u is tangent of x. So I know that tangent of x equals 1 plus the square root of 3, that's 1, or, let me move it over a bit. All right, tangent of x equals 1 minus the square root of 3, that's a minus. There, okay. All right, so I have no idea where those
We
are.
must use the calculator.
So I'm going to say, on the calculator, I'm going to say x equals the tangent inverse of 1 plus square root of 3, or x equals the tangent inverse of 1 minus the square root of 3. And I get two lovely answers. For the first one, I'm going to say x1 equals,
Ooh, wait a minute. This is positive. This is 1 plus 1.7, so we expect a quadrant 1 angle.
oh yes, it's a positive plus a positive, quadrant 1. All right, so we get x equals 1.2199
Plus pi k,
plus pi k, because the period for tangent is
It's not 2 pi.
it's pi.
And notice, this is 1 minus 1.7, so this is negative, so it's going to be quadrant 4, but it's special quadrant 4.
Okay, so this is x2 equals negative 0.632 plus pi k.
And let's see what that means on our graph up here, okay? 1.219-ish. All right. Let's see. 4 points. Let's see. Where
It's about
are
right
we?
there.
I think it's that one right there. Okay? And if we add pi to it, we get that one. Okay?
And the negative 0.63 is about right there. And if I add a pi to that, it would be there.
So we can see that by these two solutions alone, this would give us, and if you expand the graph, it would give us every point, every solution. This gives us all solutions. So when some of you ask the question, well, how do we know when to use the plus pi k and plus 2 pi k and junk like that? Well, you use those when you're finding every single time that that value occurs.
If
All
it
right?
says solve, you find it with pi k, 2 pi k, whatever. Period plus k.
All right, so let's look at our answer. If we just go to the circle here, 1.299, 1.219, okay, that's up here somewhere because this is 1.57. So there's 1.2199. This is in the quadrant where both are positive, but guess what? Tangent has the same values where both are negative, so that's going to happen down here. That is, again, adding pi. If we just add pi, we go from that red point to that red point. The other one is negative 0.632. That's probably about right there. And we have a negative value in this quadrant because y is negative, but x is positive. Well, in this quadrant, reverse the signs, and you add pi, and you get to that. So that is what is going on.
Okay. So go to section 8.3 and work number 49 with no calculators and number 52 with no calculators. Show all your work. And here's your last thing you need to do. One new thing you learned, one good question, 2 old skills that are important to recall for this material. See you guys next class.
Bye.